In this problem, we are asked to evaluate a trigonometric integral. Now, we know this is a trigonometric integral because we have a power of one trig function being multiplied by a power of another trig function. In this chapter, we usually learn about problems in which sine and cosine are being multiplied, or in which tangent and secant are being multiplied. But here we have a bit of a strange mixture of cosine being multiplied by tangent. So that's kind of what makes this question a little bit difficult. And to undo that difficulty, we're going to have to rely upon a trigonometric identity. Now, let's all recall that the tangent of x is equal to the sine of x over the cosine of x. That's just a basic trig identity. If we look back at our problem, we have the tangent cubed of x. So what we would do is basically cube both sides of this identity. And by doing that, we would have the tangent cubed of x is equal to the sine cubed of x divided by the cosine cubed of x. So we're going to replace that tangent cubed of x with this expression right here. And then if we look carefully, we can see that we have two factors of cosine in the numerator and three factors in the denominator. So we can cancel out two of those factors. These will just become one. And then in the bottom, because we're canceling away two of them, we're just going to be left with a single cosine of x. So right now we have the integral of 7 sine cubed of x. And then this is all over the cosine of x because we have that extra power of cosine of x in the denominator. So now we have a trigonometric integral that involves sine and cosine, which is just a little bit more familiar. Let's take a look at the strategy that we can adopt to solve this. And here we have that strategy, and this strategy works if the power of sine is odd. If we look back at our problem, we indeed have an odd power of sine. It's sine to the power of 3, which is an odd number. So we're going to follow this approach, and what we're going to do is save one of those three factors of sine. So when you rewrite the integral, you're going to kind of separate one factor of sine. So you'll have sine of x, and then that's going to be multiplied by sine squared of x. And then this will be divided still by the cosine of x dx. So that's your first step in this process. Whenever you have a power of sine that is odd, you want to save just one factor of sine. The next thing that you want to do is use this identity right here. We can see that the sine squared of x, which we have right there, is equal to 1 minus cosine squared of x. So we're going to be able to rewrite the integral again, and we will make that substitution. Sine squared of x will be 1 minus cosine squared of x, like so. All divided by the cosine of x dx here. This material right here you can kind of disregard. You can jump right over to the final step, which is letting u equal the cosine of x. And so that's your third step. And back here was the second step, letting u equal the cosine of x. So this becomes a standard u substitution that you probably learned about in previous chapters. So u will equal the cosine of x. You would then differentiate both sides. You would have du equals, hopefully we all recall that the derivative of the cosine of x is negative sine of x, and then dx. And then what I like to do is solve this for the dx. So in order to solve for dx, I would divide both sides of this little equation by negative sine of x. These would cancel out, and that would leave me with my dx. Now, because this is a u substitution problem, we're going to go back and make our little substitutions here. So look back at the original integral. You have the integral of 7, and then you have this sine of x times 1 minus. Now, instead of cosine squared of x, we're going to be able to say u squared, because remember, u was equal to the cosine of x. So you can think of this expression right here as being 1 minus the u squared. And that's what we're going to have down here. And then this will all be divided by, well, in the original it's cosine of x, but our substitution requires us to put in u. And then times dx. Remember, we solved for dx. It was equal to du over negative sine of x. And what's really nice is this factor of sine of x and that factor of sine of x will cancel out, and that's going to leave you with a negative 1 in the denominator. Now look carefully, and you have 7 divided by that negative 1. That's a negative 7, and you can factor that constant of negative 7 to the outside of the integral. So now you're left with the integral of 1 minus u squared all over u du. This is a much simpler integral to evaluate than the original, but we're not ready yet. So we're going to take advantage of this little simplification. We're going to kind of separate the numerator. So we'll have 1 over u minus u squared over u. That's an equivalent way of writing this expression right here. We can simplify over here. We have u squared divided by u to the 1. Recall that you would subtract those exponents. So 2 minus 1, of course, is just 1. That leaves you with a minus u to the 1. And then you still have this 1 over u right here. Now we can finally integrate. We'll take this little 1 off here because it's implied. We recall that the integral of 1 over u is the natural log of the absolute value of u minus, and then for the integral of just u, you recall that the integral of u to the power of n is equal to u to the power of n plus 1 all over n plus 1. So basically, you're just adding 1 to this exponent. So it becomes u to the power of 2, all divided by 2. Close off your parenthesis, add your constant of integration. The last little step is to recall that the u was the cosine of x. That was our original substitution from earlier. So you just have to make sure you replace that u with the cosine of x. So you'll have the natural log of the absolute value of cosine of x minus cosine squared of x over 2 plus c. Notice it was cosine squared of x, of course, because the u was squared. This would be your final answer.